So how can we use the Pythagorean identity to solve problems like this? We have between the radius, or the radian, negative 3 pi over 2 and negative pi, we have our angle, okay? And the sine of that angle is 1/3. So we're going to kind of tie on all of these ideas here. And the first thing I want to talk about, I guess, I'm going to draw a picture first. So we have our unit circle. Whoa. And here's my best to draw a circle. Yikes. Okay, so now these are negative angles, so that means I'm moving clockwise. All right, so if I were to move clockwise, here's a half, here's pi, so this is like negative pi right here, and this is 3/2, so negative 3 pi over 2, that's right here. So we are in the second quadrant. We're here somewhere, and our point has the sign of 1/3. So that means that my basically, well, we'll just leave that here. So we're talking about some angle over here. We don't need to be totally specific with that 1/3. So we're talking about something out here. Sine of angle is 1/3. Sine of theta is 1/3. La, la, la. And so this is going to help us. We're going to be using the quadrant 2 information up here. Bam. Sine is positive, and that is true for the situation. It is positive 1/3, but our cosine is going to be negative. So let's find our cosine using the Pythagorean identity. And that says sine squared theta plus cosine squared theta is equal to 1. All right, so sine theta is 1/3. So I could really just say 1/3 squared. Okay, don't forget that squared. Plus cosine squared theta is equal to 1. All right, well, 1/3 squared, 1 squared is 1, 3 squared is 9. And then we have cosine squared theta equals 1. Okay, so I can subtract, and 1 is equal to 9 over 9, right? We're all comfortable with that idea. So we can subtract 1/9 from both sides. So cosine squared theta is equal to 8/9 when I subtract that 1/9. And when I take the square root of both sides to find out what cosine is, remember square roots can be positive or negative, and I want the negative version because this is in the second quadrant. So cosine is negative. Okay, so I want this is going to be negative. Put that in there. The square root of 8, I don't know right off the top of my head. I'm just going to leave it like that. The square root of 9 is 3, so I can write that here. And that's going to be equal to my cosine of theta. All right, so we can simplify this a little bit more. What's a perfect square that goes into 8? Well, 4 goes in there, right? So this is like the square root of 4 times 2 over 3. And so the square root of 4, that would come to the outside. This is negative 2 root 2 over 3. That's our cosine. Okay, so I'm going to put that in a box. That's our cosine. All right, now, a little tidbit here to help. When I find tangent of theta, okay, because I need to find cosine and tangent, that is equal to my y over x, or I'm going to go back up here. Y is the same thing as sine. X is the same thing as cosine. So we want sine theta over cosine theta. So sine theta was 1/3, all divided by my cosine of theta. I could use this one, but I suggest you go back and you use this simpler version. So I'm going to put this in here for cosine, negative 8, sorry, square root of 8, negative square root of 8 over 3. Okay, because these are equivalent. I'm going to use this one because it'll be a little simpler to reduce here. When I'm dividing two fractions, I can multiply by the reciprocal. So this is 1/3 times, the reciprocal of this would be 3 over the negative square root of 8, right? So this is why it becomes simpler. These reduce. That's nice. So then we are ending up with negative 1 over the square root of 8. All right, normally we don't like to leave a radical in the denominator. So I can multiply by the square root of 8 on top and bottom. All right, so now I have tangent of theta is equal to, it's going to be negative still, and we know that from this box up here too. Tangent's negative. Square root of 8 over 8, because the square root of 8 times the square root of 8 is just 8. And then we know that the square root of 8 reduces to to root 2. So final answer, negative 2 root 2 over 8. And we can simplify, last step, and write it up here. Tangent of theta is equal to, that would go in 1 time, 4 times, so negative root 2 over 4. Final answer. All right. So I know it's a lot of little algebra steps. Please pause that video if that was too fast. But it's really just multiplying and substitution, and like not craziness. Okay, so the next example I'll do, let's see, wait, look what's next. Okay, yeah, I'll do one more example and then I'll have you guys practice. Okay, so given that theta sub 1, so just some angle, is located in quadrant 2, and cosine of theta sub 1 is equal to negative 13 over 17, find sine theta sub 1 and tangent of theta sub 1. So same idea, we're in quadrant 2. This means that, I'm just going to put a little note, sine is positive and tangent's negative. Okay, negative something. Okay, so let's start with that Pythagorean identity. Sine squared theta plus cosine squared theta is equal to 1. And now we're given cosine. So let's go here. Negative 13 over 17 squared. And that's equal to 1. All right, so you'll notice that even when you square a negative, it becomes positive. So I'm going to just do this. Let's see, 13 times 13 is 169. So we've got sine squared theta plus 169 over 17 squared is 289. Okay, whoa. And I'm going to get a common denominator here, so I'm going to write 1 as 289 divided by 289, because that is just 1. All right, so then I can subtract 169 from both sides. So we get sine squared theta is equal to 120 over 289. I subtracted 169 from 289. That's 120. And then I can take the square root of both sides. So I'm going to kind of smush this in right here. Sine of theta is equal to the square root of these, 120 over 289. Well, 289 is a perfect square. We just did that. Square root of 289 is 17. And then let's think, what's a perfect square that goes into 120? And I know 4 does. This is kind of how I'm going to check. Okay. 120 divided by 4. 30. Can I think of any other perfect squares that go into that? 4 does not. 9 does not. 16 does not. 25, no. So I think that's it. So we can write this as 4 times 30. All right, so then this becomes sine of theta is equal to 2 root 30 over 17. Put that in the box. All right, so now I can find the tangent of theta, and this should end up being negative. I'm going to save all the room I can. So tangent of theta is going to be sine over cosine. And I'm going to go and I'm going to use this value right here. So square root of 120 over 17. Okay, so I'm just going to kind of simplify this version of that. All divided by cosine, which was negative 13 over 17. Okay, so this is equal to the square root of 120 over 17 times, and I'm going to flip this fraction, 17 over negative 13. So these simplify, and we have the square root of 120 on top over negative 13, and we know that the square root of 120, I'll write this over here, tangent of theta, the square root of 120 becomes 2 root 30 all over negative 13. That is our tangent. Not too shabby. All right, please pause the video now and try the next two practices. All right, hopefully you're all back. I'm going to show you how to do these two. All right, so we have an angle between negative pi over 2 and 0. So let's draw a little unit circle here and talk about that. All right, so if we are moving backwards, because it's a negative angle, negative pi over 2 is right here, 0 is right here. So we are somewhere in quadrant 4, chilling on this triangle in here. And sine is negative 2/3. All right, so I'm going to go grab, here is our information. We're in quadrant 4. So sine is negative, cosine is positive, and tangent's negative. So just kind of keep that in the back of your mind. I'm going to write it up here. So sine is negative. Yes, it is. Cosine is positive. Tangent is negative. Okay. All right. So now I'm going to find cosine using my Pythagorean identity. Oh, sorry, plus. Okay. Sine of theta is negative 2/3 squared plus the cosine squared is equal to 1. All right, this would be 4/9 when we square that times cosine squared theta is equal to 1. We can also write 1 as 9 over 9. So I can subtract 4/9 from each side, right? Okay, so this is cosine squared theta is equal to 5/9. So then cosine of theta is root 5 over 3. I take the square root of both sides. Put that in a box. Alrighty. Next, we can find tangent. Tangent is equal to sine of theta over cosine of theta. That's tangent of theta. Okay, so sine of theta we just said was negative 2/3 all divided by root 5 over 3 for my cosine. So then I can multiply by this reciprocal. The 3's eliminate. And so we are left with negative 2 over root 5. So I can multiply by root 5 over root 5 to rationalize that denominator. And we're left with tangent of theta is equal to negative 2 root 5 over 5. Put that thing in a box. Bam. Last one. Theta is located in quadrant 3. Sorry, I have a double cosine thing happening here. All right, so quadrant 3, which means cosine is negative, sine is also negative, and tangent is positive. Okay, so we want to find sine and tangent. More typos here. Okay, so we've got, let's see, sine squared theta plus cosine squared theta is equal to 1. I know my cosine is negative 11 over 14. I'm going to square that, and I'm looking for sine of theta. All right, so I can do 11 squared. You might know that off the top of your head is 121, but there it is. And then 14 squared is 196. So we have sine squared theta is equal to, plus 121 over 196 is equal to 1. All right, now 1 we can write as 121 over, oh wait, no, sorry, I should do 196 over 196, so we have a common denominator. So then I can subtract 121 over 196 from both sides. All right, so that is gone. I have sine squared theta all by itself. And 196 minus 121 is 75. So we have 75 over 196. All right, when I take the square root of this, bam, bam, I get sine of theta is equal to the square root of 75. I'm going to let that be for a second, over 14. All right, and we can think, what's a perfect square that goes into 75? And hopefully you're all thinking, oh, well, 25 does 3 times. So then we can take the square root of 25, and that is 5. Got the root 3, and we got the 14. All right, one thing to be careful of here. Every time we take a square root, it can be positive or negative, and we need it to be negative. So this is negative 5 root 3 over 14. I'm going to put this in a box. That's our sine of theta. And then I can find tangent. Tangent of theta says take this sine value. I'm going to take this one right here, root 75 over 14, divided by my cosine, which is, oh, sorry, that should be negative 2, and should be negative 11 over 14. So this becomes negative root 75 over 14 times negative 14 over 11. Those cancel out. We've got a negative times a negative, which is positive, and that's what we want. So root 75 over 11. We can write root 75 as this. So tangent of theta is equal to 5 root 3 over 11. There you go. If you need more practice with this, and you might, please try the Pythagorean identity practices in Khan Academy.